problem, let's first understand it. What's the question is asking us? So basically, we are given a array which basically represents the heights of the rectangular bars, and we have to find out the largest rectangle in this histogram. As you can see here in this example, there are bars of height 2, 1, 5, 6, 2, 3. And if we are to calculate the largest area in this particular histogram, this should be this particular area. Okay. Now let's first understand inner concept which involves in this particular question. If I consider this particular example where there are some blocks, four blocks of different heights present there, if I consider this particular block, then we have to first determine how this particular block is contributing to the area. Okay, so if I consider this particular block, then we can see that this particular block is contributing to this much area only. Why? Because as you can see, it cannot contribute to the previous blocks or next blocks because they are smaller than it. So this particular block will contribute to this much area only. If I consider this example, this particular block which is highlighted will contribute to this much area only, because to find out the area we have to take continuous blocks. And as you can see here in this particular block, right side there are no other blocks, and on the left side it is not continuous because the next block is lesser in height, so this block cannot contribute to the previous blocks in any way. Okay, if I consider this particular example, if I consider this particular block, then this particular block will not only contribute to itself but also contribute to all the previous blocks and also the next block which are lesser than or equal to its height. As you can see, this on the right hand side, the block is greater than its own height, so it will basically contribute to this much area. And also on the left hand side, it will continue to contribute in all those area which are lesser than or equal to its height. So here, if I have to compute this in terms of formula, then we can say that for a particular height of I, the contribution of that particular height will be equals to height of I into left of I minus right of I minus 1. Now what is this left of I? Left of I is previous smaller block, and this right of I is next smaller block. Okay, so previous smaller block, next smaller block, minus 1. So let's understand this with the help of dry run. So let's continue. Let's see this example. There is 2, 1, 5, 6, 2, 3 blocks. Okay. So for this, we'll be using a stack. Here I have used a stack which will contain height, comma int. So I'll be taking a pair class of height and index. So for each of the block, we need to find out the next smaller blocks, and for each of the block, we need to find out the previous smaller block. So let's first move on with the next smaller. So I'll be using a stack here. So this is a stack, and I'll be using height comma index. So this will be a pair of height comma index. So for the first block, which is 2, there is no element in the next smaller stack. So we can enter 2 comma 0, the height and index. For the next block, which is 1, we can see that there is already an element in the stack which is 2 comma 0. Its height is 2 and our current block is 1. So our current block is lesser in height than the existing block. So we will pop out this, and its index is 0. So we'll go to the next smaller array, and in its index, which is 0, we will enter the index of the current block, which is 1. And since there are no more elements, we will enter the current block, which is height 1 and index is 1. Now we will carry on to the next block, which is 5. In this particular block 5, we can see that it is greater than the existing element in the stack. So we will not do anything. We'll enter 5 comma its index, which is 2. Now move on to the next block, which is 6. Now 6 is also greater than the existing block in the stack, so we will not do anything. We will enter 6 comma its index 3. Now as we move on to the index 2, we can see that its block height is lesser than the stack top, that is 6. 2 is lesser than 6, so therefore we'll pop out this element 6 comma 3. What it says index, it is 3. We'll go to the index 3 of next smaller, and we will enter the index of the current block, which is 4. Now we'll again see the topmost element in the stack, which is 5 comma 2. Its height is 5 and our current height is 2, so obviously it is lesser than the stack top. So we'll again pop out this element and we'll go to its index, which is 2, and we will enter the index of the current block, which is again 4. Now we will again see to the stack top, which is 1, and our current block 2 is not greater, it's not lesser than 1, so we will not do anything, and we will enter the current block, which is 2 comma 4. Then we'll move on to the next block, which is 3, and we can see that 3 is not lesser than the existing element on the stack, that is 2. So we will enter 3 comma 5 in the stack, and eventually we come to an end, and all those indexes where there is nothing in the next smaller, we can enter the length of the histogram, which is 6. So this particular array, which is next smaller, basically denotes for each index what is the index, what is the position of the next block whose height is lesser than that particular block. For example, if you can see here 0, whose height is 2, the index here is 1, this particular block whose height is lesser than the block 2. Now let's find out the previous smaller for each of the blocks. So we'll start from the end. The current block is 3 and there is no element in the stack, so we will enter 3 comma its index, which is 5. Okay, so the next block is 2. The block 2 is lesser than the existing element, the existing height on the stack, so we can pop out this element. What's its index? It is 5, so we can go to the index 5 and we can enter the index of the current block, which is 4. So for this particular block at 5, the previous smaller element is at index 4. Now we can enter uh, the element which is height 2 index 4 in the stack. Now move on to the next block, which is 6. Now 6 is greater in height than existing element in the stack, so we can enter 6 comma the index 3. Now as we move on to the 5, then we can see that the 5 height is lesser than the stack top height, which is 6. So we can definitely pop out 6 comma 3. 6 comma 3 is popped out. What its index? It is 3. So we will go to the index 3 and we will write the index of the current block, which is 2. So for block 6, its previous smaller is at index 2, which is 5. Now we will again look to the stack top, which is 2. Now 5 is not lesser than 2, so we will not pop out and we can enter 5 at index 2 on the stack. Okay. Now as we move on to the next block, which is 1, we can see that 1 is lesser in height than stack top. So we can pop out stack top, which is 5. We can go to its index, which is 2, and we can enter the index of the current block, which is 1. Again we look onto the stack, which is 2 comma 4. Height is lesser. We can pop out this element, go to its index, which is 4, and we can write the index of the current block, which is 1. Now the stack is empty. We will enter the current block, which is 1 at index 1. Now we go on to the index 2 and we see that the index 2 is greater in height, so we will not pop out, we will enter 2 comma 0. Now whatever indexes are empty, we will just write -1, which denotes that for this particular block there is no element on the left hand side which is smaller than this, so therefore we will enter -1. Now that we have our next smaller index and previous smaller index ready, we can use this to uh, compute the result which a particular block is contributing. For example, if we find out for this particular block, which is 6, we can see that its height is 6. So therefore the formula, as you can see here, the height of I into left of I minus right of I minus 1. Here left of I is previous smaller, right of I is the next smaller, minus 1. So for this particular block, which is 6, if I find out the contribution of 6, then we can see that height is 6 into the next smaller for index 6, for block 6 it is 3. So go to the index 3, it is 4. So 4 minus the previous smaller, which is 2, minus 1. So the answer will be 6 minus 1. So 6 into 1, 6. So its contribution to the area is 6, which is only this block. Similarly, if we find out for this particular block, which is 5, then its contribution will be the height of this particular block into next smaller of this particular block, which can be found out from this array, which is 4, minus the previous smaller of this particular block, which can be found out from here, which is 1 minus 1. If I compute this, the answer will be 5 into 2 and it will be 10. Definitely this particular block 5 will contribute to this much area, which is 10. So this is how, if I can compute the next smaller index and the previous smaller index, I can find out the answer for each particular block easily. So overall fundamental concept of this particular problem is to prepare the next smaller uh, array, to prepare the previous smaller array, and then we will iterate through each of the height, and for a particular height the contribution to the area would be computed as height of I into next smaller element of I minus previous smaller element of I minus 1. And since the question is asking us to find out the largest area, so we'll have something called answer, which will be initially 0, and we will find the max of answer comma particular contribution of height I. So let's see the code, and this particular approach will be very much clear from the code. If I look at the code, as mentioned earlier, I have prepared a pair class of height and index. There are two arrays, next smaller element and previous smaller element. So for the next smaller element, I have filled this with the length of the array, and for previous smaller, I have filled this with minus 1. So taken a stack of pairs. Here I have computing the next smaller, and here I am computing the previous smaller. Then I am iterating over the blocks, and for each of the block I am computing the current block contribution, which is current height into next smaller of I minus previous smaller of I minus 1. And then I am taking the maximum of current block contribution and answer, and then you have to return the answer.